rate of change in y with respect to x. So it's like your rise over run, where your rise is your y and your run is your x. The other one is your instantaneous rate of change. I'm going to use delta instead of the word change. In what? X with respect to y. So it's still a rise over run, but your rise is actually your change in x and your run's your change in y. So it's a different sort of approach to the same idea of a tangent. Okay, next one. Now things will really start to kind of get crazy. How about x squared y cubed equals x plus 3y? Find d, we'll go dy dt. What's the first thing you notice? There is no t. Yeah, so where before we said, okay, this was our independent variable, so anytime we said anytime we saw that variable in our problem, we'd say the derivative of it is 1, right? And anything that doesn't have that, the derivative would be either like the y prime or the x prime, right? In this case, since t doesn't appear there, I have to treat x and y as if they both depend on t, and so I'm going to have x prime and y prime. I treat them both like primes. And this is where using the other notation is better. So that's what I'm going to do in this problem. I'm going to do it two ways, and I'll highlight the way that I think you should do it. So what is the derivative on the left? We've got product rule, right? What's the derivative of x squared with respect to t? 2x x prime, okay, times y cubed, plus 3y squared y prime x squared. Done with product rule, right? Equals right side, derivative of x, x prime, plus derivative of 3y, 3y prime. Now that's acceptable, but when we say prime, when you write it like that, you're not telling me what the independent variable is there. So the preferred way to write this answer would be 2x dx what? dt y cubed plus 3y squared what? dy dt x squared equals d what? dx dt plus 3 dy dt. What is it that I was trying to find? dy dt. Doesn't that appear here and here? Couldn't you get those terms on one side by itself? Move everything else to the other side. Factor and solve. You could do that, right? Same way we did before. But what is it that you would need to know? Like if I actually wanted to know the value of dy dt, what things would you have to know? What things do we not have in that equation? You would have to give me a value for what? X, y, right? X and y would take care of those. But I would also have to know what? dx dt. Not only would you have to tell me the x and the y, you would have to tell me how fast x is changing with respect to t. And then I could tell you how fast y is changing with respect to t. So I have to know a lot more to answer a question, but I could. And this is this is going to lead us into 2.7. Any questions? a lot of times this right here is called the total derivative, because you're treating every variable as if it depends on something else that's not there. Where the other ones, the variable that you were differentiating with respect to actually appeared in the equation. Are there any other requests out of 2.6? I plan on doing one more problem, but I wanted to give you an opportunity to have one more request. Okay, good. They're asking for a double prime, a second derivative. So we have 9x squared plus y squared equals 9. And we want to find y double prime. What that means is we're going to take the derivative of y with respect to x, and then we're going to take the derivative again with respect to x. Okay, that's what we're going to do. So find the derivative first time and then second. So there are different ways of doing this, but let's just try it. What's the derivative of 9x squared with respect to what variable? With respect to x. So what's the derivative of 9x squared? 18x. What's the derivative of y squared? 2y, y prime, equals 0. Agreed? Now, it would be pretty easy to get y prime by itself right now, wouldn't it? But I'm actually not going to do that. I'm going to go for the second derivative, and I'm going to do it implicitly again. What's the derivative of 18x with respect to x? 18. Plus, now, what rule do I have happening here with 2y, y prime? Product, and I'm going to split it right down in between the y's. What's the derivative of 2y with respect to x? 2y prime. Times y prime again, plus what's the derivative of y prime with respect to x? Y double prime. Times 2y equals 0. You see how that blue part is the product rule on that piece there? And now I could get y double prime by itself. I think I will. I'm just going to clean it up. 18 plus, watch how I write this, 2y prime squared plus y double prime times 2y equals 0. Be careful there, because y prime times y prime is not y double prime, right? Y prime times y prime is y prime squared. There's a difference, right? So I'm going to move the 18 and the other part to the other side. So it becomes negative 18 minus 2y prime squared. And then divide by what? 2y. So I'm going to reduce everything by 2. Negative 9 minus y prime squared all over what? Y. So I really divided by 2y, but I already canceled out a factor of 2 from everything. That's it. Now, the book probably doesn't have that answer. The book probably takes this part up here, where we had y prime. They probably move the 18x to the other side, and then divide by 2y to get negative 9x over y. Do y'all agree that that's what y prime would be? And then they probably take that answer and plug it right in here and square it. And that would give you negative, that would give you negative 9 minus, when I square that, I get 81x squared over y squared, then over y. And then what do you think they do? Get a common denominator, right? Put those together on the top. And then flip the fraction and clean it up. I think I'll finish right there, though. Good question. Okay, I'm gonna have to make one up here. I don't know how this is gonna work. Let's just try this. This is the last problem for this section. Okay, where is slope of tangent line of curve x y squared plus x squared y equals 2 equal to 1. So someone in layman's terms tell me what this is asking. Like if you're trying to explain this to someone. Where's the slope 1, right? This curve, we draw it, right? Where on that curve is the slope 1? Yeah, where's the derivative? So where's that tangent line 1? Now, I just made this problem up just out of the blue. So real quick, I want to make sure it's going to have a slope of 1. It may not, because I made it up. What was the problem again? Was it x squared y?
X, y squared plus x squared y.
Whoa. xy squared plus x squared y equals 2. I don't know if it needs 2 equal signs. Sometimes I forget what program I'm... Okay, not to understand. Try it again. Okay. Hey, I'm feeling pretty good about this because it looks like somewhere over here I'm going to have a slope of 1, right? And it looks like down here I'm going to have a slope of 1. Now I'm a little concerned because there's 2 places, and I'm not sure the algebra that's going to be involved for this, but it might get ugly, okay? But hey, have no fear. We'll figure it out, hopefully. Okay, first thing I'll do is take the derivative. Okay, here's my derivative. Will you tell me? 1 times... Yeah, be careful. There's product rule 2 places there. So 1 times y squared plus 2y y prime x plus 2x y plus y prime x squared equals 0. There's your derivative. Everyone agree with that? That's a great. I'm glad you asked. Y prime, unless otherwise told, means dy dx. Okay, it's going to be what it's always been from the beginning. Unless you're told to differentiate with respect to some other variable, always assume it's dy dx. It does, but you can look at slopes 2 different ways. You could say dx dy also, the change in x with respect to y. So it depends, but our standard slope of a tangent line is dy dx. All right.